There is a thing you learn after working on real software for a while. Sometimes writing the code is not the actual hard part. The hard part is understanding what the code is actually supposed to represent. Because on paper, the task can look simple. Change this behavior, add this field, fix this bug, update this one condition. But then you start asking questions and suddenly the simple task grows teeth. Who uses this flow? What should happen to existing data? Is this a one-time exception or is this a new business rule? Does this apply to all users or only some users? What happens when the old behavior was not a bug but something people quietly depended on? And this is the part of software engineering that I think we don't talk about enough. Code is often the visible work, and today often done by AI, right? But context is the work underneath the work. And when context is wrong, the code can be clean, reviewed, tested, and still solve the wrong problem. And that is painful, but it is also one of the most important lessons that you can learn as a developer. Because early in your career, it is very tempting to treat a ticket like a truth. You open the ticket, you read the description, you look at the acceptance criteria, you think, okay, I understand what needs to be done, let's do it. And sometimes that is true. But often the ticket is not the truth. The ticket is someone's current best attempt to describe the truth. It's a translation, right? Someone saw a problem, someone explained it, someone else wrote it down, someone maybe simplified it along the way, someone prioritized it, and by the time it reaches you, a lot of context may already be missing. Not because people are bad at their jobs, just because real systems are messy. And people assume things are obvious, teams forget why all decisions were made. Business rules live in people's head instead of written down, and legacy behavior becomes invisible until someone changes it. And users always do things nobody expected. This is why some bugs don't really start in the code. They start in assumptions. I thought this value could never be empty. I thought this job only runs once. I thought this customer type was not supported anymore. I thought nobody used this screen. I thought this old behavior was wrong until it wasn't. I thought this was just a small change. Famous last words, right? These words are dangerous, not because assumptions are always bad. You cannot work without some assumptions, but unspoken assumptions are where a lot of expensive mistakes hide. And this is where good developers become valuable. Not because they ask clever questions. Usually they ask very boring questions. What problem are you actually solving? Who is affected by this change? What should stay exactly the same? What could break? Who understands the old behavior? What does success look like? Is this a temporary fix or are we creating a new rule? It doesn't sound impressive. It does not look like deep engineering from the outside, but one good question before implementation can save days of very elegant and expensive waste. And I think this is one of the big differences between just writing code and doing actual engineering work. Writing code is turning instructions into a behavior, but engineering is making sure those instructions actually make sense in reality. And that is much harder. Because code gives you errors, context often gives you just silence. Your compiler will complain if your syntax is wrong. Your tests may complain if the expected output changes, but context does not always complain immediately. Context waits. It waits until a customer uses the system differently. It waits until another team depends on the old behavior you actually removed. It waits until production data does not look like your test data. It waits until someone says, wait, why does it work like this? Why? And maybe then the code is already merged, even deployed and shipped, and maybe it's clean and following the best practice. It's just based on a wrong understanding. So my practical advice is simple. Before you rush into implementation, slow down just enough to check context. Not forever, not in analysis paralysis way, but enough to avoid building confidently in the wrong direction. Ask what the ticket does not say. Ask what should not change. Ask who knows the messy history. Ask what assumptions would hurt the most if it was wrong. And after that, write the answers down. I repeat, write these answers down. Because context that only lives in Slack messages and random conversations will disappear fast. This does not mean that coding is easy in some absolute sense. Of course it's not, even with AI today. Programming can be really hard, debugging can be hard, architecture can be demanding, but in real teams, the technical difficulty is often only part of the job. The deeper difficulty is understanding the world that the code is supposed to model. The rules, the domain, the people, edge cases, trade-offs, all decisions everyone forgot, hidden constraints, the things nobody wrote down because everyone thought everyone else knew them, and it's self-obvious. So if you want to become more valuable as a developer, don't only get better at writing code. Get better at decoding and describing context. Because code is how we express our understanding. And if the understanding is wrong, the code can be clean, tested, reviewed, and still completely wrong. That is the part that actually hurts. But it is also where a lot of real engineering growth happens. I hope this was useful. Tell me what you think in the comments, and see you around with the next one.